IP addresses alone will not ensure that the data payload in a packet gets delivered to an application. To deliver data to the application layer of the network model, port numbers play an important role. This tutorial shows how port numbers and IP addresses work together to allow data to flow between client and server applications. We'll start with an example here. To the left we have a server with an IP address here, and this server has various services or applications that are running on it. So it has a POP3 mail server, a web server, and an FTP server. Clients will make requests to this server to retrieve mail, retrieve a web page, or to retrieve files. Now, port numbers at the transport layer play an important part for directing traffic to applications. The port numbers below 1,000 are generally called the well-known port numbers, and many of them are assigned to certain services. For instance, POP3 mail has a port number called numbered 110. Web uses port number 80, and FTP uses 20 and 21. We'll just use 21 here for an example. Once an application on the server starts up, so a POP3 mail service starts, it sort of registers its ports with some of the software on the TCP stack, and we say that port 110 is now open. And what that means is that any packets that come in with the server's IP address, a port number is also looked at, and if the port is 110, then the POP3 mail is going to listen to that packet or it's going to process it. So 110 port is open. We also say, you may hear the term listening. The server is listening on port 110. Okay, well, we've got a client over here, and for the client at the application layer, we have a browser open. It could be Chrome or it could be Internet Explorer, and we also have Outlook, which is a mail client. So our client here is going to connect with the server to request two things. One is the browser is going to request a web page, and Outlook is going to request mail to see if there's any mail for it to receive. So what happens? How do these packets get constructed? Now, I'm not going to write out all the IP addresses for the client and for the server. I'm just going to put the letter CL, and that'll represent 16.32.100.8, and I'm going to use the letters SE to represent this number, which would be in the actual packet. But let's suppose we start up our Outlook client, and it's been configured to know where the mail server is, and the client wants to request some mail. So the data payload here would ask a question, hey, do I have any mail? And there would be a numerical format for this instruction. Now at the transport layer, there is a port number which has to get assigned, which is called a source port number. And a source port number, it's going to use something above 1,000, we'll say 1,020, as the source port number, and the destination port number is the port number of the service that has registered to use that port. So if we're looking at POP3 mail, it always uses 110. So the destination port number that's going to get constructed, so what we're doing is we're constructing a packet on our client. It's going to use 110. As this travels down and this data payload is being processed by the various layers of the model, we're going to add some internet addressing. And so we're going to add the source address will be, I'll just use CL here, my client address. My destination will be the server, and I'm just going to put SE here. So if we're constructing this packet, you'll notice that in the data payload we've asked a question. Do I have any mail? And that's going to get encapsulated by some layer 4 information for a destination port. Destination is 110. The source port is 1020. This is just some random port that's assigned. There's no real significance. Next time Outlook uses or makes a mail request, it could use any other port above 1000. However, the destination port is always 110. That's assigned to POP3 mail. So this is encapsulated. We might have some error checking in here. As this travels down to the internet layer, the destination IP address is going to be 142.16.34.8. I'll just put SE here to indicate that. And the source IP address is the client address. And there's some error checking going on here. And what happens is that port gets sent out and delivered to the network card of the server. So what the server does with this is that the server looks first at this packet and looks at the IP addressing information. It looks at the destination address. Okay, it sees, that's my IP address. So it's going to process that packet by stripping off the internet layer encapsulation. It's going to remember that this packet came from this address, CL address here, and it's going to pass it up to the transport layer. Now, this is destined for port 110, and so this packet will be directed up to the application layer to the POP3 mail server. The POP3 mail server, the transport layer will also, as it's passing it on, will strip off this information and it passes along this question, this data payload. The POP3 mail is going to process that question and it's going to send mail back to the client. So now it's going to say, here's your mail messages, and that's going to constitute the data payload. As it's passing down to the transport layer, so we'll construct this packet. This is your mail. The destination port, well, it's remembered the destination port from the source port that it received. Okay, so this was the source port that sent this packet. So the destination port is going to be 1020. The source, the server source port is 110. So the transport layer encapsulates that data, adds some error checking. As it goes down to the internet layer, this server in the source address is going to send its IP address. It knows that it received the packet from this client, so it knows to send back to that IP address, and this gets sent back to the network card here. Now my browser is also open at the same time, and I could be making a request for a internet web page. So we'll show that could be happening at the same time. So I'm going to say get a web page. Maybe something a little better for color. So again, this is being sent out, so it has to have a source and a destination port. The destination port for web pages is 80, so it's going to use that port. The source port is just some random port to keep track of returning traffic. So it's just something above 1000, maybe 1080. As it goes down to the internet layer, the source is the client, the destination is our server over here. So it's going to construct a packet here that's going to try to get a web page. It's going to make this request. The source port could be 1080. The destination port has to be 80. It's just an HTTP request, and HTTP uses port 80. The source address is CL, this number here. The destination is SE. And so this also gets sent to the same network card. Because the destination address is the same as the server, it gets processed, it keeps track of who sent the packet, and this gets stripped off. And the port addresses get sent up to the transport layer. And notice that I have the destination source port mixed up here. My destination port should have been 80. My source port was 1080. So when it looks at the destination port, it knows here that the web application has registered port 80, and so it knows not to send it to the POP3 mail or an FTP, but to strip off this information. It does keep track of the source port, and to send this, the data payload, up to the web application, which gets the web page. This server sends back a response. It's going to send back the web page. So this is the actual web page that gets sent back as data. Since the source port for the request was 1080, the destination port is going to be 1080. It's coming from the port 80 service, and it knows that the destination going back is going to be the client, and it comes from the server. So we have both of these going back to the client, and it could be at the same time, or roughly the same time. So as this packet comes into the client, it looks at the destination address. It sees, that's the same as my IP address, so I'm going to strip off this information, and I'm going to pass that up to the transport layer. The transport layer looks at the destination port, 1020, and that got registered when the mail request was sent out. That was remembered, and so 1020 is registered with the Outlook application. So this gets stripped off, and this data payload gets delivered to Outlook. So your mail messages get processed by my client. Meanwhile, the next packet that gets processed is this one down here. Use blue for this one. As it comes in, we see again that the destination address is for the client, so the client says, at the internet layer, says, yes, that's for me, so I'm going to process it. I'm going to strip this off. I'm going to pass this segment here up to the next layer, the transport layer. The destination is 1080, and 1080 was remembered by the software as being registered by the browser. So this gets stripped off, and this information gets passed to the browser, which is the actual web page, and that gets displayed in your browser. So this is an example of how port numbers help direct traffic. Once a packet's inside and being processed by a computer, it directs it to various applications, and these are all handled through port numbers.